Okay, we're rolling. So welcome everyone. This is our last meetup of the year 2021. Trying to remember which year it is. And we're happy to have Prem and Vladimir from TigerGraph joining us tonight. Excited to learn about TigerGraph and graph databases and what you can do with them. And so I'm going to turn it over to you guys. Welcome.
Fantastic. Thanks, David. And thanks to all of you for taking the time to join us today. It's good to be with you. And David, thanks to you and the entire RBA data engineering team for hosting. We certainly appreciate the opportunity to spend the next hour with you. So we have basically two parts here. I'm going to go through some slide material just to give you an overview of Graph, what it is, and really dive into use cases and where it's applicable across a broad range of industries. Then I'm going to turn it over to Vlad, and he will walk us through a demo and what a graph environment looks like. And then we'll save some time in the end for questions as well. So what I'm going to do is I'm going to share my screen. Hopefully you all can see my screen.
Yep, I'm seeing it.
Okay, perfect. All right. So quick, a few seconds on us as a company. So TigerGraph, founded in 2012, been around for about 9 years now. We were in stealth mode for the first 5 years. Basically a very high performance graph database. And you can have it deployed either on-prem or you can have it in the cloud. We work with all the major cloud providers, and our solutions are highly scalable, and they're seen in a wide variety of verticals. You can see them mentioned here. So, if you have any questions, feel free to reach out to myself or any of the folks here. There's a couple of other teammates as well. Or you can just reach out to me and I'll point you in the right direction. I'm just prem@tigergraph.com. Pretty easy to get to. So before we talk about graph databases and graph analytics and so on, it helps to understand what's the problem that we're trying to solve, right? Where is graph really a good fit? And if you look at the way data has been stored, for the last 3-4 decades, the main platform has been relational databases, right? So basically you have data stored in tables with rows and columns, and the data is typically not in one huge table, but it's sprinkled across multiple tables. And when you're trying to get information on something, you grab data from one table and then the next table and the next table, and then you stitch it all together. And that process of stitching together is called a join, a table join. And that process of joining the tables can be quite painful when you deal with very large data sets. Sometimes it can be an overnight job. Sometimes it can be a couple of days. Sometimes it's longer. Also, when you look at the database structure or the schema, it's usually reflecting what the business is trying to do. But as the business evolves, making changes to the schema is not trivial. So there's these kinds of challenges and others which really caused people to go and look for, is there some other alternative? And that's where really graphs started to get much more attention. So just to do a little bit of a level set, what is a graph? Right, let's start there and have some foundations from which we can build, right? I'm going to illustrate that by means of an example. So if you look at this example here, you can see a customer is buying something, right? So you place an order, and the customer makes a payment. The order, if there's an order, that you notify a supplier. The order ships from location 1, it's going to location 2. Why? Because the customer resides in location 2. So you have this idea of a node, which is a person, a place, or a thing. And you have relationships between those nodes, right? So customer, location 2. Those are two nodes. What's the relationship between them? Well, customer resides in location 2, right? So it's a very intuitive, natural way of representing the data, fundamentally very different from the tables and rows and columns that we talked about before. Obviously, the folks at TigerGraph and really, anyone in the graph space is going to be very passionate about graph and the kinds of things you can do with it. But it's also nice to see some third-party validation of that excitement and passion. So here's a quote from the folks at Gartner, where you can see that right now the graph is still kind of in its early stages, but they expect that by the year 2025, 80%, it's a pretty significant number of data and analytics innovations will involve graph. And you can see the quote there, to graph or not to graph, that's not the question. You will graph, right? And we'll see why in the subsequent slides and the different areas of the business where graph is applicable. And just to wrap up this section, is graph new? Is this some, new technology, some fad? Not really. Graph as a concept, for those of you that have a theoretical background, you'll know that graph has been around for about 3 centuries. And as far as industry-wide deployments are concerned, graph has gotten a lot of attention really within the last 5 to 10 years. There's a bunch of names here that I'm sure you'll recognize. If I go onto Netflix and I watch Home Alone, it's going to come back and say, people who watched Home Alone also saw this other movie. Well, that's a recommendation engine. And those things are powered by graph. Facebook, Prem is friends with Alice. Alice is friends with Bob. Bob is friends with Charles. Prem is also friends with Charles. It's not tables with rows and columns that Facebook uses to keep track of 1 billion odd users. It's a graph. Right? Same with LinkedIn, Amazon, lots of other companies are leveraging this technology. And what TigerGraph is doing is really bringing this technology into enterprise level and enterprise scale and making it more mainstream. Okay, so let's dive into use cases. I'm going to start with entity resolution, and closely related to that is Customer 360. And the reason I'm starting with that is because that's one that we encounter a lot. So I think it's a good place to start. If you look at the 3 lines that I put on the screen there, right? For those of us, looking at this, it's pretty easy to tell that all 3 of those lines refer to the same place, right? But to a computer, it's not so obvious, right? This is, W, 45th Street. This one says West, but then the street got abbreviated and so on. So to computers, this looks like 3 different things. And when you look at customer data that is scattered across the enterprise, right? Some of it is on-prem, some of it is in the cloud, and you might have Robert Smith, sometimes it's Rob, sometimes it's Bob, sometimes Bobby. You get all these variations, but at the end of the day, it's all referring to the same customer or the same household, or maybe you're doing a product level analysis. So you want, for companies, they really want to have that ability to go across all the different data sets and get this universal ID from which they can derive insights about a particular customer or a particular household. Why? Because now that can help with things like better sales and marketing campaigns, right? Also, one of the things I touched on earlier, and it's very applicable here as well, is graph, because of its fundamental flexibility, as the business evolves, you can change the schema very easily. Let me give you an example just to illustrate this. So you have mom and dad, and let's say this is a financial institution. So mom and dad have an account, and maybe they have a checking account, savings account, maybe they have a brokerage account as well. In fact, I was talking to a financial institution recently, and they were talking about how the kids are now coming of age and they have their own accounts, but their spending habits are different. For those that have an interest in investing in companies, they might be looking at companies that are very different from mom and dad. Maybe there's some environmental causes or social causes, or whatever it is. So they all have different profiles, but it all comes under the same household, right? So it's very interesting for them, for that financial institution, because now they can come up with marketing campaigns very tailored to the children and different ones that are tailored to mom and dad. You look at a company like Amazon, right? I get onto Amazon to buy, backpacks and, books for my kids or whatever. I'll go to Whole Foods down the street from me to buy stuff in the groceries. And I'll also go onto Prime to watch my favorite TV shows. But it's me. It's still the same person every time. Regardless of which side of the business, regardless of whether I come in through a laptop or a tablet or a smartphone, it's the same person. So getting that holistic view of me, looking at all that different data that's there and understanding this is Prem. He sometimes, buys stuff online. Sometimes he goes to the store. Sometimes he's watching shows. But let's really understand all the data on Prem. And Graph is just fantastic at making those relationships, because Graph, its strength lies in the fact that it looks at interconnected data, right? And you're going to see that time and again in the different examples as well. Shifting gears a little bit, here's a different use case, cybersecurity. So there's lots of different examples in the cybersecurity. You can look at fraud. You can look at, in the telecom world, you have things like robocalls, you have financial fraud, you have denial of service attacks, you have attacks coming from the outside like DDoS, you got attacks from the inside, where you have maybe data loss prevention, where people are data is leaving the organization, and the security organization wants to stop that. And you want to not only know who is doing that, but also you want to know who else are they communicating with, because that way you find the bad actor and you find the community around that bad actor. So those kinds of relationships, again, Graph is really strong at community detection. What I'm showing here in this visual is you can see different parts of the stack. You got the web layer, you got the network stack, looking at protocol level, you got moving up the stack to the email level. You got different products that are working in different parts of the stacks, and each one will have its own alarms and events and so on. But as a human looking at this, it's really overwhelming. If I have 100 events in front of me, it's not humanly possible to look at all of them with the same level of attention and care that would be required. So it would be great if you could somehow find the relationships between those events and filter stuff out and say, hey, Mr. Operator, or whoever's looking at this, look at these 10, right? But how do you find that? And that's where TigerGraph or any graph, it's not just TigerGraph, but any graph platform can do this very, very elegantly by taking the events from the different platforms and aggregating it and finding relationships. Let's look at a different use case, supply chain. We're seeing mention of supply chain all over the news now. And if you look at this from left to right, here you got bill of materials. So you got different parts, and the parts are used to make equipment. Then the equipment goes into factories. Well, it's made in factories, and then it goes into warehouses and eventually to a distribution center. And then it makes its way to customers. And how does it get to the customers? Sometimes by rail, sometimes by roads, sometimes put it on a plane. But you can see everything is very interconnected. And when you want to look at things like cost optimization or impact analysis, what if node 11 here were to fail? Who are the customers that are impacted as a result of that? Finding those kinds of answers to those kinds of questions, Graph is really, really good at that, right? It's one of the strengths of Graph. I'll mention one more use case here, digital twins. This is where you got a real-time system and you have a digital replica of that. And you can see here, this is where the real world system is. So that could be Maybe it's a car that's giving data about fuel efficiency, mileage, and other metrics that is calculating. Maybe it's an aircraft engine where you're getting performance data. Maybe it's a water treatment plant. The possibilities are endless. It's feeding data back into the digital replica. Lots of analytics and calculations are being done here. And then that's going back into the real world system. So you can make adjustments on the fly. So it's very much this constant feedback loop where the real world system ultimately is getting better because of the data that's being collected from the real world network. So there was just a few use cases, but let's look at some verticals and how you might apply this. So we talked about customer 360 in the beginning and having that holistic view of a customer. Well, if you look at a healthcare example, here you have Doris Smith, and when she calls in, the call center agent can see all the information about her right there on the screen. You got the number of times she called, number of visits, pharmacy information, any claims, etc. All that, and it's not stored in one place. It's stored in hundreds of data sets. So being able to quickly go through all those relationships and pull the information that you need for Doris Smith in real time, very hard to do. And that's the kind of a challenge that Graph is really good at solving. I'd like to direct your attention to this button here, find similar members. So when Doris is talking about a particular condition, the call center agent can say, find me people similar to Doris who've experienced this, and we'd love to make those same recommendations and not reinvent the wheel, right? Again, the interconnectedness of this problem makes Graph an excellent solution. Financial services, another vertical where there's a lot of interest and activity with Graph. Here's a few use cases, anti-money laundering, you got fraud, credit card fraud, transaction fraud. One of our customers was dealing with money laundering, and they have investigators who look at the data and maybe it looks like John Smith is engaging in some money laundering, and they do some due diligence and they find out that, oh, there's nothing there. We thought there was something, but it turns out there isn't. That's a false positive. And that's very time consuming. And, at the end of the day, it's very frustrating for the investigators. So this is where a Graph platform is hugely helpful to really speed up that process and look at the interconnectedness and with all the different data sets to see if there is money laundering and reduce the number of false positives. And for this particular bank, what that ultimately led to was a reduction in the number of fines that they were paying as a result of false positives and the money laundering use case. Fraud, credit card fraud, not just finding out who is doing it, but also the devices that they're using. Is it you want to have low-level network data, SIM card data, cookies, and so on. Because with fraud, what happens is you might see a transaction that happens in New Jersey, but once you trace the breadcrumbs, it might be somewhere in Hamburg, Germany. And because these guys are so good at covering their tracks, you need to be able to go hop by hop by hop to figure out where the source of the problem is. And that's where Graph is, again, very well suited for these kinds of problems. I'll mention one more. I spent 25 years in the telco world, so this is a space that's near and dear to my heart. Graph is great for telco. Why? Because telcos collect all kinds of data, whether it's data coming from the network, you got billing records, also known as CDRs, or call detail records. You got your CRM system, you got DPI data, deep packet inspection, which is looking at network level. You got different applications, YouTube, Netflix, and so on. And you can also scrub, let's say, a Twitter feed to see what are people saying out there. And you want to be able to connect all these even though they're all in different silos, being able to connect them. You can, as a telco, you can go to a partner with a retail outfit and say, okay, it looks like people in the age bracket 18 to 35, typically they're interested in this, this, and this, and they hang out in Union Square. Well, okay, so maybe this store, the next place where they want to open up a shop is in Union Square because they want to go after that particular demographic and that age group. Being able to take these data sets and doing it at scale and finding the relationships, again, Graph is really good at that. There are plenty of others. I can go on and on, but I'll mention one more here. And marketing campaigns. If I have $1,000 that I want to use for gift cards, let's say, I can do $5 gift cards for 200 people, or maybe I do $50 gift cards for 20 people. But then how do I find those 20 people? Well, Graph is very good at finding influences and who is really connected broadly, and where will I get my best return on my investment, right? So rather than just a blind, let's just put it out there and see what happens, you can take a much more surgical, methodical approach and apply those $50 gift cards to the place where you'll get the best return for your money. And lastly, we've talked about all this graph technology, but what about the average business user? Do they need to learn all this graph stuff? And the answer is no. If somebody is out there in finance or marketing or any other business function, what they're going to see on a day-to-day basis is something like this. So here you can see a screen for a financial institution. Here's a customer. They have a savings account. They have a mortgage account. They have a credit card account. There's a bunch of credit card transactions. There's a couple of disputes. It's just very natural. It makes sense. They don't even need to know that underlying, technology for all this is Graph. They just need to know that the insights are there and they can go about doing their jobs and have the data at their fingertips very quickly. That's really the promise of Graph here. Being able to look at large data sets, break down the silos. The data is very interconnected. Let's take advantage of those relationships and get the results in the hands of the business users quickly. So I'll pause there and let me stop sharing, and I'll turn it over to Vlad, and he'll walk us through a demo. And we have some time at the end where you're welcome to ask questions. But I did put my email address there if anyone wants to jot it down, and you can reach out to me even after the meeting. Very happy to answer questions. But let me stop sharing here and I'll turn it over to Vlad.
Okay, thank you, Prem. That was excellent. Great overview of really the breadth of potential graph applications there. So what I kind of want to do before I jump directly into the product, just a couple more slides, if you guys will bear with me, to kind of to hammer home some of these points Prem was making, maybe a little bit more from an abstract, slightly theoretical angle. So I'm going to go ahead and share my screen here. Let me put this thing into presenter view. So, right, we have all of these various use cases, but hopefully you're starting to connect the dots here. And you're hopefully beginning to understand, well, graph fundamentally is at its core a study of the relationships of your data within your data. This is very critical to understand, right? Trying to perform what is essentially relationship mining in a RDBMS, in a relational database, in your Oracles, your MySQLs, even in your key value stores, MongoDB, for example, trying to extract things like customer journeys, sequential paths, similarities, trying to perform user segmentation and clustering, all of those kind of things in those systems is computationally unfeasible because of the way the data is structured, the way the data is stored. Within Graph, a lot of this is made possible. Oftentimes our customers come to us and they're really looking to do complex pattern matching, right? Understanding a sequence of a user journey. A customer bought product A on a certain day, then product B, then product C, so on and so forth. There's a temporal dimension here. How can we find all of the other customers that have the same sequence of events, right? That's really powerful. That'll give us new insights. That allows for potential predictive capabilities further down the line when you're actually leveraging graph for machine learning capabilities. We have unsupervised community detection capabilities natively within graph, trying to determine what are the communities, what are the people in my data who interact with other people. What are these communities of possibly transactions, all of these complex networks. To try to derive those communities, again, in an RDBMS, very, very complex, very hard to do. Oftentimes, these kind of queries will take weeks to run, right? Especially when you have large amounts of data. With TigerGraph, really the foundation to be able to do this kind of complex pattern mining and matching, complex community detections, especially from a temporal perspective. To be able to do all of that, you need to go deep into your data, multiple hops deep, right? When we think of this from a relational perspective, it could be multiple self joins into the tables, right? This is very, very expensive. And to be able to have a system, really, this is where TigerGraph shines. We can go 5, 10, 12, 15 plus hops deep into your data in order to performantly execute your community detection algorithms, in order to performantly do this kind of deep data pattern matching and pattern mining, right? The horsepower, the architecture that we provide enables this. And I'll hopefully have a moment to kind of get into a little bit of that. Now, one thing I kind of wanted you guys to visualize, what this might look like from the actual data perspective. Here we have a bunch of community clusters. Today, my focus point is going to be more on the financial side of things, users and transactions, because that conceptually kind of translates very well for most people. Imagine here you have 1, 2, 3, 4, 5 different clusters, and they're kind of color coded for your convenience. With graph, what we're able to do is first derive clusters, right, based on various similarity patterns or various other metrics. And we can understand in this cluster, we have a community of people interacting with each other. Now, it may be a suspicious community, right? For example, you have a bunch of users here who have multiple flag transactions within each other. How is this particular community connected to, let's say, this blue community, right? There's a lot of interactions going on here. You can kind of see that this graph is very, very dense. Okay, just by virtue of the fact that this graph is dense, these people have a lot of interactions between each other. By that notion alone, it's suspect. You have a very tightly knit suspect community. People shouldn't have this kind of a pattern. This is something that graph analysis, again, can detect and then can expose in a visualizable manner. How about, well, what if we have one particular person and there's a transaction between this orange network and then this teal network, right? And you can kind of see this connection right here between the circle and triangle. Well, to be able to find this connection, again, this is something very, very difficult to be able to do in RDBMS. In graph and with graph analytics, it's very, very straightforward and very performant. Now you see the bridge connection between communities. You're going to be able to know, you can tell your data analyst, for example, to go and focus on this person, see what else he's doing, see people who might be similar to him, because now you will have an insight into where communities start to talk to each other. Right? This is a very tangible example from the real world. Now, oops, there we go. So again, from the TigerGraph perspective, right, Prem has mentioned graph has been around for decades. Actually, in some concepts, in some ways, graph even precedes RDBMS. Now, it's never really been at the forefront of a lot of business use cases simply because it can't scale. It's very hard. Anyone with a graph theory background will tell you scaling a graph, partitioning a graph, it's super difficult. Well, with TigerGraph, we're able to really accomplish this. Our ability is handling massive data scales. We can scale well into the terabytes of data. And we're able to do this because of our performant architecture. We can take a single graph and then split it across a cluster, right? And this is not just a read-only cluster. This is both write and reads go to every machine across that cluster. It allows you to deploy these really, really performant, powerful algorithms and leverage the entire compute of your entire system, because TigerGraph is an MPP processing database. So just a little bit about that architecture. Now, that preamble aside, I'm going to go ahead and jump into the solution itself. So this is something that we put in the hands of most data analysts, your DBAs, your programmers. This is bundled with every deployment of TigerGraph. This is TigerGraph Graph Studio. What you're able to do here is actually begin to design your graph schema, begin to perform your graph explorations, execute queries, execute these complex algorithms against the graph to really derive all of these insights. What does this look like, right? When we're starting when we're going into our graph exploration. This is a simple graph schema. This is a very simple use case. What we're representing here is essentially a Cash App or a Venmo. We have a user transaction system. We have our vertices and edges, like Prem talked about. Now, this actually is really similar to what you might see from a RDBMS perspective. Our users, you can conceptually consider this a user table, basically, right? Now, in graph, this is a vertex. And for each user, right, you have multiple different attributes. You might have the time that they came into your system. You might have their mobile information. You might have a trust score here as part of a fraud algorithm. Okay, this particular user is connected to your devices. Similarly, right, they need to access Venmo from various phones, your Apple tablets, so on and so forth. That device token is also stored into the system. Every user, of course, they have payment instruments, your credit cards, your bank cards, so on and so forth. Users can invite other users to Venmo, right? I can invite someone into my Cash App app, okay, one of my friends. And then lastly, of course, we have the actual transaction records because a user transacts with another user on Venmo. That schema modeling, that conceptualization, right, that I just went through, it's kind of very semantic, right? If you understand how a payment network is structured, it's very easy to translate that notion into a graph. And very similarly across the board with pretty much any other use case. If you understand the data, if you understand the relationships within the data, modeling everything in graph is quite straightforward and quite simple. And also really easy, right? You don't have to have this perfect right out of the box. With an RDBMS, it can be pretty tough to actually change your schema once you have it set in stone. Not the case in graph. It's very easy to add additional edges, very easy to add additional vertices as your business entities without affecting any of the underlying data. Now, a little bit from the from the housekeeping perspective. What is really, really powerful, a lot of developers, they love this capability. When you're talking about mapping the data in the system, when you're mapping your raw CSV files, maybe we can import data from your various Kafka queues, we can import it from Spark, what have you. We can digest data in many, many different ways, but mapping the data is really, really easy in our system. We have basically a front-end UI utility here where it's super easy to map and perform the data, perform your data transformations. It's very nice. And the great thing at the end of the day, right, when you're going to be productionizing this deployment, well, you just export all of these data mappings and then you're given a data load script at the end of the day. So you don't actually have to start from code to begin with. You have this great UI utility and you can just kind of let the front end, so to speak, do a lot of the hard and heavy lifting for you. Now, going again, talking more about just the graph itself. What I can do here, now this is again, something that not every graph database vendor has out there, right? The ability to actually visualize your underlying database records. So before, when I showed you the database schema, it's going to look very similar to the underlying data records, right? Here you have your actual users. I have 1, 2, 3, 4, 5 of them. If I double click on a user, what you see here are all of the connected transactions, all of the devices the user used, all of the payment banking instruments that that user used. Right now, I'm actually looking at over 250 gigs of data in this particular example. So just being able to double click on this and get all of this connected stuff immediately, right? This kind of just talks to the performance of this data storage mechanism, right? Of the ability to store the data in the graph. Now, every user, of course, they have a transaction. When I click on the transaction, I get the user on the other end of that transaction. I double click on that person, right? Then I see the various other people and transactions and so on and so forth for that particular user, right? I keep kind of going deeper and deeper into this, and you get this essentially topology, really. And this is something to keep in mind. All of this graph, when you model your data in a graph, you are actually showing there is a hidden meaning, a hidden pattern to your data. There's a topology that we can leverage. And there's a lot of hidden secrets in here, right? For instance, the ability to find a connection from a particular user. Let's say I have one user here on one side of the graph. And then if I want to understand, well, how is this user connected to a potential payment instrument somewhere deep in my data? I don't know. Well, with Graph, this is a simple front-end query that we actually have directly available in the UI. This is a connection mining query. Well, right there, see, this is more than 6 hops into the data. Let's kind of look deeper and see what we can find. Right now, again, we're searching through 250 gigs, and almost in real time, we're seeing this connection path, right? This one particular person referred a given user who referred someone else. Then they received a transaction. Then again, that transaction was received by a different user, and so on and so forth down the chain of events until we find this pattern, right? Imagine trying to do something like this in RDBMS, arbitrarily, ad hoc, trying to link a user to a particular banking transaction or to a particular device or payment instrument. It's almost unfeasible, right? In Graph, this is done in a matter of sub-second, quite frankly. And the power of TigerGraph is to be able to go this many hops deep into your queries, this many hops deep into your data, excuse me. Now, this is just kind of the tip of the iceberg in terms of what can be done. When we take a look at the queries themselves, there is a lot that can be extrapolated. Now, for instance, if we have something like a circle detection query, right? We want to understand circuitous or circular paths within our data. Now, this is particularly important from an AML perspective. If we have a user, let's say user 35, we run this query. Again, look at all of these potential looping paths that we have, right? This can all be, this is all potentially indicative of fraudulent behavior. When you have a lot of these tight kind of transaction loops that are happening. For this particular user, I think there might be 6 or 7 transaction loops, right? We can take that, we can count the fact that this guy has 6 of these looping connections within our system, and we can use that as part of a fraud score or a fraud metric, right? So we can hone in on this particular person. Now, this kind of analysis, again, extremely non-performant in anything but a graph database. A little bit further, right? Prem mentioned things about determining user influence, right? Now, I have an algorithm here. This is a PageRank algorithm, and this is, again, one of those classic graph algorithms. And what this allows us to do is determine in my system here, in my Venmo, who is the most influential user within my database, right? And what does that mean? The user who may have invited the most other users within my system. Okay, so doing something like this is a very classic graph algorithm here. And these are just some of the parameters that we're specifying for my query. Now, some of you data science folks might be familiar with this. I'm going to go ahead and print out all of my results. And I run this thing, and I'm going to get essentially a JSON output, right? So every query in TigerGraph, everything that you write here, it's exposed as an API endpoint. So if you're trying to build a customer 360 solution on top of this, if you're trying to build a some sort of an application, it's very easy to take this data and then essentially change and transform it however you want, visualize it however you want on the front end. But again, with this PageRank query, we see that we have a particular vertex here, a particular user, and they have a high PageRank score. That means they are particularly influential in my data versus someone else who has a very low ranking score of influence. And when I see this in my graph exploration, I can go ahead and expand. What that's really telling me is, hey, this guy has 3 or 4, in this cases, 4 users who are also very influential, right? So this gentleman has a PageRank score of 1.56. These folks have also relative differing PageRanks, right? So this guy is influential because some of these other users are influential within my system, and so on and so forth. That algorithm propagates. Okay, these kind of recursive deep pattern type of analyses are very, very non-performant to execute in RDBMS. And lastly, right, when we're talking about graph, clustering is at the top of everyone's minds, right? Trying to performantly determine, find clusters, communities, k-means, if you guys are data science inclined. Again, when we do something like this in graph, we can visualize this really well. And this is both a product of Graph Studio and then a product of how we structure our queries. What we have here, this is another graph algorithm. This is a label propagation algorithm. And what we see, we have these kind of pseudo clusters of similar users, right? I'm able to determine that in this particular cluster, we have these users of varying similarity. These users are similar to each other. Why? Well, they may have had the same types of bank records. They may have had similar transactions. They may have had similar numbers of transactions, right? And I'm able to create these really powerful clusters. And then when I have a new user that comes into my system, almost in real time, in most cases, I can go ahead and assign them to the proper community. This is, again, very, very powerful, this kind of analysis that can be performed in graph. Now, I can kind of go on and on. I do want to leave some time here for questions, but the key point that I want you guys to take away here, again, graph is an analysis of relationships. Now, how do I get started with all of this stuff, right? It's a question of signing up on TgCloud.io. Now, we of course have, you can go ahead and download TigerGraph, download our binaries from our website. But a lot of folks, just when they're starting out, they just want a simple plug and play database as a service solution. And this is exactly what we offer with TgCloud. Really easy to log in and register. I just kind of SSO'd in there through Google. You can go ahead and create your own account. And when you get in here and you go into the My Solutions tab, what you're able to do is spin up basically the solution that I just talked about. So I click on Create Solution. And let's say, right, I was talking about an anti-fraud use case. We have all sorts of different use cases that you can use. And all of this stuff, when I go ahead and deploy a fraud or money laundering detection use case, what I'm actually going to be getting out of the box is a schema, a bunch of queries, and then data upon which I can perform all of this exploration. It's kind of a test bed to let you guys play around with the system to start off. And then you can go in there and using our Amazon, this is a free tier deployment. This is all free. You can go in and you can start creating various queries and just playing with the system as much as you'd like, exploring all sorts of different use cases. So it's very easy to deploy this. And again, this is just deploying an EC2 instance. I go through here, I fill in the required password, the subdomain, so on and so forth. It's all pretty straightforward. And then, right, you end up with something that is very actionable, and you can really get a strong appreciation and understanding of this concept of exploring the relationships within your data. So with that, folks, I'm gonna wrap it up. Now, kind of wanna leave, I guess the last, what do we have, 10 or so minutes for some questions, anything extra that I might be able to jump into, show some specifics, or that Prem might answer.
Thanks, Vlad. So any questions in the audience that
do you ever use the math form of graph theory? Like, which types of graphs do you use?
So I'm sorry. So which types of graphs?
Yeah, like I'm really interested in math and graph theory. So like, are there any certain types of graphs you usually use?
So Vlad, before you joined, Bobby was telling me that he's got a background in math and graph theory. So he's coming at it from a more theoretical academic perspective.
Right. Well, so a couple of things. Now, TigerGraph, we are a property graph, first and foremost. Right. You have different types of graphs out there. You have like RDF graphs and things like that. We are a property graph. Now, by nature, as you probably inferred from the schema that we have, we can do both homogeneous and heterogeneous graphs. Does that kind of answer your question?
Oh, okay. Well, it was good, but yeah, I really am interested in graph theory. Okay.
So there's a lot of really cool stuff that we can do. And for folks such as yourself, right, what we actually provide is a Python driver for your, if you want to perform explorations, if you want to do some machine learning, right? Not only, I didn't get into this too much, but not only can you do some of that learning actually within the graph, right? We do have learning algorithms that you can deploy within TigerGraph, but you can connect this, of course, to all of your other ML frameworks. And we offer a Python driver. You can go in with Jupyter notebooks, do all of that, powerful feature extraction, right? You want to understand page ranks. You want to understand, you want to run a Louvain detection community and extract those community IDs for various features, things of that nature. You can do all of that right from within the comfort of Python using our driver. And then, of course, perform your machine learning either within the graph when it makes sense or outside of the graph.
I have a couple questions. Some of the problems I hear talked about a lot in the space that I work in has to do with managing access to different data parameters. For example, you want this specific group to be able to have access to maybe this column, right, during queries, and you want this specific group to not have access to that column during queries. But if you have a property graph that really relies on basically being able to see a lot of these properties, then how do you manage segmenting different parts of the data within queries?
Excellent question. I will quickly share my screen. In TigerGraph, we have this capability called Multigraph. And if you, in this particular example that I have, we have the choice to actually create a global graph or essentially create a bunch of logical subgraphs on top of that. So you can basically essentially limit access to various parts of the graph, right? To various, we're actually really granular with that. You can limit access even to certain vertices. So you can actually go ahead and slice and dice that however you need, depending on your business requirements. But at the end of the day, right, you're actually looking at a single graph. So this is very different, right, than many other a lot of other vendors out there. They will start from that bottom up approach, and they'll be like, well, okay, you have to create. You can deploy one server, it's going to have this particular slice of the graph. On another server, it's going to have this particular graph schema. On a fourth server, you'll have another graph schema. TigerGraph doesn't work that way, right? You deploy a single graph across that houses all of your data, and then you can slice and dice that data logically, right? But at the same time, the queries that you're running, they are not just limited to that small subgraph. They are running against the entirety of your data. So I hope that answers your question.
Yeah, no, thank you. I appreciate that. Sorry, if anybody else has another question, jump in, because I'm on to question number 2 right now. I know from some of the work on smaller graphs I've done that different queries, and I'm thinking of something called a snowball sample query, right, can have radically different results. And if you're talking about graphs at scale, right, really, really huge graphs, then how do you manage the parallelism across, the hardware if that parallelism could change radically between 2 queries of the same data?
So TigerGraph, right? We are natively an MPP database. Now, the way that we actually perform our query processing, it's I believe the actual underlying theoretical algorithm is it's called BSP or bulk synchronous processing. I have to kind of recall that, but essentially it's a message passing framework. It's very MapReduce like. So there is an innate level of parallelism in how we access the graph. And it's essentially, it is a message passing framework. So you may be starting at one particular user vertex, and then there's an activation function that basically propagates to all of the adjacent edges, right? And then another message is passed from every other vertex, and so on and so forth. And it kind of expands. And it's a very, it's just innately parallelized, right? Against other solutions, you do have to do a lot of manual parallelization. There are certain libraries that you're going to have to invoke to get all that to working. In TigerGraph, you don't, because query processing by default is in this very parallelized manner.
Okay, awesome. Thank you.
And again, to a little bit further to your point, right? When you are talking about going into many terabytes, right? Imagine performing something like a Louvain community detection against many terabytes. Well, in that case, right, there are elements, there is a level of heuristics that comes into play, right? That modularity that might, of course, change over time. And we have ways, we have solution architects on staff that can help kind of rein in that query, make those results very reproducible. But again, a lot of our algorithms as well, they are freely available on GitHub, and it's just, it's as, in order to deploy them, all you're really doing, you can just literally copy paste one of our algorithms directly into GStudio and run it on your graph, right? Because they are schema agnostic. This is looking at the graph topology.
And one last question. I'm pretty sure I know the answer to it, but I need to ask it anyways, right? I'm thinking about if you go from like a large query where you're looking at properties, but then you need to run specific metrics within a graph that has a uniform type of, let's say, edge and node type, certain types of centrality or something like that. You're able to switch between those levels of granularity in your queries? So
I'm having a little bit of difficulty exactly kind of understanding. I mean, I'm probably the answer here is yes. Our programming language it's actually it has declarative and imperative components. It's fairly low level, right? And as the system, let's say if you are performing a query, if you're doing your PageRank or whatever, and it's running from node to node and executing that processing, it's able to look at the various attributes on every vertex. And this is something that you can modify directly in the code, right? So if you're looking at multiple different transactions of differing amounts, you can basically sum up all of those amounts as the query is propagating throughout the graph, and then use that for another type of computation. So there's a massive amount of flexibility, and this is why we can run something like a Louvain community detection algorithm, right? Very complex, very expensive algorithm. This is actually written in our programming language. It's not written in like Java or something like that. We're able to do that because our language is very, very expressive. So I'm going to hazard a yes to your answer there.
Okay, cool. No, that's what I figured. The background I come from is done a lot of social network analysis. And so of course, those are much smaller scale than the stuff you guys are talking about. But it is an area I'm still working in. So very cool. Very cool stuff. Thank you.
Thank you.
I'm going to go mess around with it.
Yeah, enjoy. It's fun.
Vlad.
Yeah.
Hey, Vlad, there was a question in the chat window. Is GSQL what you would use to switch from traversal mode to analytics mode?
So when there's no real mode within the platform, and again, let me share my screen. When we perform that that kind of deep link query that I showed you guys earlier, where I went from, let's see, I think it was. I have to kind of run it again because again, our system does not use any caching here. So when we want to go from this particular user to, let's say, another user, right? And we want to mine this connection. So this connection, again, very, very deep in the graph, right? This is probably what I'm assuming you guys are thinking about being traversal mode. All this is really is just a front-end UI function. And on the back end, there's actually some GSQL that's running to execute this traversal. So GSQL is being used really from the get-go. So you can, so this is an out-of-the-box pre-baked query that you can use during graph exploration, but you can, this same thing, this result, right? You can code this traversal directly in GSQL as well. So there's not really a change in modes there. GSQL is kind of applicable throughout. And hopefully that kind of answers the question.
Hey, I'm the one who asked that question, and thanks for answering it. So let's say I'm doing EDA and I'm just doing traversal analysis. I imagine that I would download the Python driver and load it on my notebook, and then probably just run GSQL on it. And when it's time for me to do label propagation or PageRank, I imagine that I'll be using GSQL as well for that. Is that a fair assumption?
Yes, correct, exactly. And again, really quickly to show you guys how a little bit of that would look like, right? This is a Google Colab, right? Which is just basically like a Jupyter notebook in the cloud. And here, you can invoke and install your TigerGraph drivers. I'm using a TigerGraph beta driver here in this case. And essentially what I'm doing here is I'm using it to basically, do some data loading, do some schema mapping, a thing of that nature. I'm also using it, of course, to connect to the database itself. Once I'm connected to the database, This is GSQL right here. So all it is, right, I'm actually writing the GSQL in my Python notebook and then doing a call to my driver to say, hey, install it in my system. Once that's there, you can go ahead and just click the play button for Google Colab or however you want, and you can actually run this thing. So when you run that, right, you're going to get some sort of results that you can then later on pipe into your other processes. But when you're talking about running a label propagation algorithm directly on the graph, this is one of our pre-built out-of-the-box queries. And as a matter of fact, I believe this is a variant of the label propagation algorithm, and you're able to write this thing directly into your Python notebook, and then shoot it off and then get essentially results. And you can, let's say, for instance, if you're talking about generating community IDs for this label propagation, you can go ahead and persist those IDs back to the vertices in your graph.
I appreciate this being both a semantic and an analytics platform, because not a lot of systems are like that. Kudos on you guys. So let's say I'm staying in this notebook. What would be a good visualization tool that would be paired with this, or is visualization actually best if I'm using the Graph Studio?
So when we're talking about, it all depends on what kind of visualization that you're looking for, right? If you're trying to have this visualized for your business analyst or something like that, and you really need an app, that's going to be a little bit beyond this, right? That's something where, hey, you can, and we help with this as well, right? We can actually help you build out a React.js dashboarding application that hooks into the APIs generated by your TigerGraph queries. Now, if you're trying to do something more of a data science-y, a quick type of visualization here, you can connect to your your various pandas libraries and whatnot, to get the various plot functions and things of that nature to actually create your ML plots and AUC, ROC curves and things of that nature. So you can kind of commingle all of this together. And then furthermore, we work with a lot of other graph visualization libraries out there. So there's a lot of flexibility. There's a lot of things that can be done. And actually we have a link, I believe it's, let's see, TigerGraph developers. I always kind of forget this link. If you go to community.tigergraph.com, and actually there's a link somewhere here to our developers, TigerGraph developers, community, this one, here I guess, yeah, developer.tigergraph.com. We have actually a lot of examples on here. A lot of folks go in, play around with our system and do precisely what you're asking for. They will have examples of Colab where you have, that's this interaction with the graph database and then having a visualization through a Plotly or something that's attached to the entire framework. So again, strongly suggest to take a look here, and something that I can I'll actually throw in the channel right there.
Yeah, thank you.
Mm-hmm.
Awesome. Well, I appreciate you guys coming today. The recording will be available probably tonight or tomorrow. And like David said, our next talk will be on Presto or /Trino. Super excited about. But again, thank you, Prem and Vlad. I really appreciate you guys coming to give talk today. And hope everyone has a good day.
Yeah,
Thank you, Brandon. Thank you, everyone, and Merry Christmas and Happy Holidays.
Yep.
Yeah, thanks, guys.
Take care, guys.
Thank you.